Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on antenna. Okay, so for this video, I'm going to define what is antenna efficiency. Okay, so most of the time, okay, antenna efficiency is actually linked to transmitter antenna. However, receiver antenna can also use this term, antenna efficiency. But like I mentioned earlier on, most of the time, okay, it actually used to quantify the efficiency of a transmitter antenna. Antenna efficiency can actually represent by this symbol. Okay, so from this formula, you can see that antenna efficiency is actually equals to the power that is actually radiated up by the antenna over to the input power to the antenna. So in short, with this equation, you can determine how efficient the antenna is, whether is it highly efficient, which means that efficiency equals to 1, or low efficiency or zero efficiency, which means that this antenna efficiency equals to 0. So this video, I will discuss all this. This will be the part 11 series discussion on antenna. So guys, if you're keen to know more about antenna, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on antenna. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask your question through the comment. Okay, before I continue, okay, I'd like to urge you guys to help this channel by like this video. Okay, when more of you guys actually like this video will have a better chances to reach out to a larger audience. So guys, give me a few seconds by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly do a quick revisit, okay, on the key parameters of antenna that I've already discussed. All this I have already discussed. So today, this video, I will discuss on antenna efficiency. This diagram here, you can see that this is what we call the radiated power. We also have the input power to the antenna. So efficiency is mainly related to the radiated power and the input power to the antenna. Let's understand what is actually antenna efficiency. Okay, antenna efficiency is simply a measure how effective an antenna actually convert the input power into electromagnetic power that radiated out, okay, which is the term of transmitter antenna. In short, you can see that basically antenna efficiency is how much input power you actually obtain, okay, for the antenna versus the power that you actually radiate out. So basically, this is what it means as an antenna efficient. Okay, it is an important parameters for us to understand the performance of an antenna. Okay, so in ideal world, we want the antenna to be as efficient as possible. Come to the definition. Antenna efficiency, as I mentioned, is actually denoted by this symbol. Okay, it's actually the ratio of the power that actually radiated by the antenna to the total power input to the antenna, which I have illustrated over here. But this is the equation to denote the antenna efficiency. So this is the power that is actually radiated out from the antenna. This power, which is the input to the antenna, the ratio between them will actually indicate the antenna efficiency. Okay, so basically for antenna efficiency is actually in between 0 and 1. 1 being ideal, very highly effective antenna, and 0 is basically very bad effective, basically nothing actually converted. So over here you can see that the ideal case is I want to have as much as power to be able to convert to the radiated power. So for 0 which means nothing actually convert into the radiated power. So this is a quick understanding of antenna efficiency. Antenna efficiency is also commonly expressed as percentage. Okay, for example, when we actually talk about efficiency of 0.5, okay, which is equivalent to 50%. Okay, so basically what you need to do is 0.5 multiplied by 100, you actually get 50%, which tells me that this antenna is actually having an efficiency of 50%. It is also frequently expressed in decibel. Okay, an efficiency of 0.1 correspond to 10% in percentage of antenna efficiency, or if you express in decibel will be minus 10 dB. Okay, another example to let you so-called much more shear. So therefore, when the efficiency is 0.5, which I have illustrated earlier on, it will be 50%, and this will equivalent to minus 3 dB in decibel. So this is a formula, okay, that I actually described earlier on. So this antenna efficiency actually distinguish, okay, it from another sometime used term, which is called the antenna total efficiency. So I like to highlight the difference between antenna efficiency and the total efficiency of the antenna. The total efficiency of an antenna is actually the radiated efficiency multiplied by the impedance mismatch, as you can see here. This is the total efficiency of an antenna. This is the antenna efficiency multiplied by the impedance mismatch. So basically, this is what it means. Okay, so when the antenna is actually connected to a transmission line, so this is actually to determine, okay, including the impedance mismatch. Okay, so this is what you want to say. So I just want to highlight the key difference between antenna efficiency and the total efficiency of the antenna. Okay, so don't mix up these two terms of efficiency. A high efficiency antenna actually radiate most of the power from its input. As I told you that if let's say antenna efficiency is equals to 1, most of the power, or in fact all the power that is actually input to the antenna, they will convert into radiation energy. In contrast, a low efficiency antenna actually lost most of its power. Okay, so all the power is lost. Okay, they can be lost in terms of all these loss, which I will describe later on. So either basically absorbed as internal loss, or what happened here is basically they actually reflected away because of impedance mismatch. Okay, keep this in mind. If we have an impedance mismatch, the transmit power or incident wave can be reflected, and this is actually indicated as a low efficiency. Let's come to the breakdown of power. Okay, so there are actually two. One is radiated power, which I think I have already described this, and you are probably aware what is actually radiated power. So this is actually the portion of input power that the antenna actually successfully convert into electromagnetic wave and radiate into space or air. So in short, okay, this radiated power is how much power that the antenna actually release into the air. So this is actually what we call radiated power. As for lost power, you can see that there are actually three terms. Okay, one is ohmic losses. So basically, this is depend on the material. For example, if you have a very good conductor material, then this loss will be as small as possible. However, if you have a lossy material, you use a lossy material, then you bound to have more loss in this ohmic loss here. So in short, this actually depend on the material that you actually use to meet the antenna. Dielectric loss, okay, if the antenna is surrounded by a lossy medium, okay, so basically this is depend on the background, okay, what kind of environment you actually has for the antenna. So this can create some dielectric loss. So you need to consider this also. Impedance mismatch loss, which I have highlighted many times. So basically the mismatch actually causes the reflected. Okay, once you have the reflected loss, then you will have this impedance mismatch loss. So as he mentioned over here, so when the impedance of the antenna does not match the transmission line or source, then there will be a reflection. And once we have a reflection, then we will have a impedance mismatch loss. Okay, the efficiency of antenna can be affected by factors. So there are actually again three. One is the design and material use, which I have illustrated. So if you use a very poor conductive material, then you are going to have more loss. So basically, you can see from here, the poor conductor or inappropriate material can lead to a higher loss. So basically, you need to find a material that is so-called less loss, so that you will have less loss in terms of the ohmic loss. Next will be on the operating frequency. Okay, different antenna, okay, they basically behave differently at different frequency. Hence, they also affect efficiency. So in short, antenna may be desired to work at a particular frequency and may not be so-called desired to work at other frequency. So hence, this is what we call the operating frequency. Okay, so if the antenna is actually operate at the so-called optimum frequency, then it will have the efficiency. If the antenna is actually used at unoptimized frequency, then you will have issue in terms of efficiency. Antenna environment, a nearby object or grounding can introduce loss or distort the radiation pattern, which I had mentioned earlier on. So basically, as you can see that the antenna efficiency actually depends on these three terms: design and the material use, the operating frequency, and also the environment that you actually use the antenna. Okay, if an antenna is spec with a 100 watt, okay, let's quickly do an example. So now input of the antenna is 100 watt and 70 watt are actually radiated. How can we actually calculate the antenna efficiency? If you still remember, this is the formula. So the power that actually radiated out is 70, as you can see here, and the power that is actually supplied to the antenna is 100. So from here, you can calculate that the antenna efficiency is 70%. Okay, I will say that most of the time we describe antenna efficiency as a percentage. So from here, you have a clear cut how effective the antenna is. So basically for this example, 70% of antenna efficiency. Let's quickly highlight a key important thing. A higher antenna efficiency means more of the input power is effectively used for radiation, which means that given the input power, okay, if we say that we have a higher antenna efficiency, which means that more power is actually converted to the radiate power. So basically, this will improve the overall system performance, okay, especially in com system, okay, which we are desire to have a highly efficiency antenna. So therefore, because in comms, the signal may be very small, or we need to boost the signal as big as possible. So therefore, we want the antenna to be as efficient as possible. So basically, this is key thing, a key parameters for antenna design. Radiate efficiency measure the ratio of power radiated by the antenna as an electromagnetic wave to the power fed into the antenna termination. Okay, so this is the definition which I have highlighted. I just want to reiterate this again. So if an antenna were a perfect ideal electrical component, okay, it will convert all the power that is actually fed into this terminal into radiate electromagnetic energy that propagate into the surrounding space. Okay, again, this is I have emphasized this is ideal. Okay, in the reality world, this is not possible, which means that whatever power that we actually supply to the antenna, we actually convert them into electromagnetic energy that actually propagate into the air. This is when antenna efficiency is equals to 1. However, like I mentioned earlier on, this is not possible because we are bound to a certain loss. And basically, the loss can be small, but it's not possible in a practical world to be 1. Antenna efficiency equals to 1. Okay, so this is what I mean here. In practice, some of the power fed into the antenna is always lost. Okay, for example, we have some mismatch. Okay, for example, 50 ohm match to 50 ohm. In the real world, there's no 50 ohm match to 50 ohm. For example, 50 ohm match to 50.2 or 50.1 ohm. So there will be some mismatch and there will be loss. You can't have exactly 50 ohm match with another 50 ohm. So a very little deviation can actually cause a mismatch between the antenna element and also the feeding network. So this is, I have so-called emphasize, you bound to have some loss because there is no perfect, both exactly 50 ohm, for example, for this case. Addition, the material of the antenna itself dissipate energy naturally, generate unintentional heat. You know that when we actually have energy, okay, they can be converted into heat energy, which is undesired. And this actually will be one form of the loss also. Together, this loss actually result in antenna radiate efficiency always being less than 100%, okay, which is mean that is 0 dB, okay, which means that everything all convert from the input to the output. Okay, in the real world, this is not possible. You bound to have some loss. Antenna efficiency is measured in an adequate chamber, okay, by feeding point into the antenna feed pad and measure the strength of the radiate electromagnetic field. Okay, so basically how you measure, okay, is basically shown by the equation earlier on. So we supply the power to the antenna, for example. So basically when we know the power that we actually supply to the antenna, next we actually measure the radiate electromagnetic field. So once we have this, we are able to compute the antenna efficiency, okay, as he mentioned here. In general, a good antenna actually radiate about 50 to 60% of the energy is considered a very good antenna. So basically, this is a typical value of antenna efficiency. Maybe now we can be design antenna efficiency close to 70%, okay, but this is roughly, okay, so-called the amount of antenna efficiency, okay, for a good antenna design. Antenna efficiency is a useful and informative measure of an antenna, okay, so-called economic efficiency, which means that relative efficiency. With a quick glance, one can evaluate that the antenna capability to utilize the power fed to the connection pad and determine the amount of power required from the radio module to achieve a certain performance level. Antenna efficiency does not take radiation direction into account, okay, making it a useful performance metric for mobile device, which typically have an omnidirection radiation pattern. So in short, okay, antenna efficiency is not a measure of whether how directive the antenna is. So we don't take the consideration of radiation direction. So basically, when we actually design mobile, okay, we actually have a omnidirection, okay, because we want to radiate the power 360 degree as compared to directive. So therefore, this antenna efficiency may be good to explain how effective the mobile device antenna is. So this is what he mentioned. Okay, in mobile device, no specific radiation direction is emphasized. However, if the antenna is intended to radiate in a specific direction, okay, so for example, we want to radiate the power in a certain direction, then maybe we would like to use an antenna gain, okay, to describe the performance. So in short, okay, when we actually use antenna efficiency, most of the time it's actually in a omnidirection, okay, which means that they radiate the power 360 degree evenly. Okay, there is no specific direction. When we actually want to describe antenna in a specific direction, then we like to use the word antenna gain. So this will be more clear, okay, to indicate, okay, how directive the antenna is based on the antenna gain. So please be sure, okay, when you describe the antenna in terms of antenna gain or antenna efficiency. Okay, it is possible for an antenna to have good efficiency, okay, which means that very high effective of conversion of input power to radiate power. Okay, however, in specific direction, okay, radiation pattern may have a nil, which means that nothing come out for a specific direction. Okay, basically this is what it means. Okay, being recorded in that particular direction. So with this, okay, I like to end my discussion on antenna efficiency. Okay, please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.